Today, let's go over a famous medium grind 75 question as a non-premium. This one I solved about almost half a year ago, so it's good to go over it. This one is called k closest points to the origin. So if you're familiar with how a x and y coordinate works in math, this one is pretty straightforward. So you're given a 2D list of integers, a matrix, and you want to basically find the k closest points to whatever this origin is. And the origin is defined as 0, 0 because that's usually the center of an x and y coordinate. The distance between 2 points on an x and y plane, so they give you the formula here, is x squared minus x1 minus x2 squared plus y1 minus y2 squared. This looks similar to the Pythagorean theorem. So basically you're getting, if you know SOHCAHTOA, so basically you're given the x coordinate and the y coordinate, and you want to subtract both of them and find the distance and take the square root. So yeah, so standard coordinate geometry. And now, so cool. So many ways to do this, but the easiest way to do this, I think, is to use a heap and iterate over our sublist and, you know, take the difference of whatever they gave you. So let's call this current x and current y. And so now, since you know that the x will always be 0 and the y will always be 0, so you can just say that current x is equal to p0 times 2, and then xy will be p1 times 2, right? And let's print current x and current y. This is squared actually, so okay, square root. Okay, so total distance is current x plus current y, and let's take the square root of that. Print total distance. Cool. So you can see there's some distances that are closer to the origin, some that are farther. So now that we have that, what we can do is push this into the heap. So heap q.heap push onto my heap. We want the actual total distance and then the actual coordinate itself, p0, which is the x coordinate, and p1, which is the y coordinate. So let's print my heap. So k closest points to the origin. So the first one would just be this one. Okay, in this case, it would be, this is not really working correctly. We want to sort by this. So why don't we just say my heap.sort, print my heap. Now we get, okay, that's more of what we want. And now we can just return. So, okay, instead of popping k times from the heap, why don't we just get the first k coordinates and then put them in a list. So for I in range k, let's make a result list. Result.append my heap I1, and this is going to be a tuple, so we have to convert it to a list. And as you can see, there you go. So works and passes all test cases. Instead of using the heap, which can sometimes get messy because you don't actually get them in sorted order, you can just sort it directly. And that's another trick that I used to use instead of popping k times from the heap here. So again, just to recap, we're iterating from left to right over each sublist, getting the x coordinate and the y coordinate of each sublist, x, y, using their formula here where you get the x times itself, which is just to the power of 2, x times itself to the power of 2, and the same with the y, and you add the x to the power of 2 plus the y to the power of 2, and then take the square root to get the distance, as you can see here. And then after that, you push the distance along with the actual coordinate to see how far it is from the origin onto a heap, and then sort it, and then get the k, the first k coordinates from the list and then return that as a list instead of a tuple. So hope this is helpful and straightforward, and thank you for watching, and see you in the next video.